Okay, for this problem, they actually give us the model right away. Instead of us trying to go through and come up with the model, now they give us the model, but since they give us the model initially, we want to analyze it by answering some of these questions. So that's the next problem that we're going to do here. So D is your displacement from the rest position, and T is going to be your time in seconds. We're answering the following based on that. Now the first one, part A, says, describe the motion of the object. Well, whenever you have something like this where you have a sine or a cosine in there, that's something where the graph goes up and down and oscillates back and forth forever. So if you see a sine or a cosine in there, all that means is that they want you to realize that this is going to be simple harmonic motion. Okay, that's what this whole section is about anyway, is simple harmonic motion. That is the motion that describes that. Again, you'll have that whenever you have a sine or cosine as part of your formula. That's considered simple harmonic motion. For part B, what's the maximum displacement from its resting position? Let's draw a little sketch here. So this little sketch, something looks like this. It may start at the origin, it may not. In this case, it would start from the origin because we have a sine graph, but the main thing is how far it is from the resting position, which would be this line right here, the x-axis. Now, how far you are away from the rest position, actually all they're asking for on this problem is they're really asking you for the amplitude. That's what all this actually says. Okay, so the amplitude, all we're going to do is read it off of our formula here, and that's going to be the number in front of the trig function. That's 4. So that's all you have to do here. You just have to recognize that it's asking you for amplitude, and we just read it directly off of the formula itself. Now this one says, what's the time required for one oscillation? This is actually the definition for period. The period would be the amount of time it takes one cycle to repeat. In this case, we're using the word oscillation instead of the word cycle, but again, it's really the same thing. So this is nothing more than your period is really what it's asking for. Okay, now the period, we can get that from the formula. This goes back to when we graphed the sine and cosine graphs. There was a formula for that. So this one, your period, is equal to 2 pi divided by omega. In this case, we're going to do 2 pi divided by the number in front of the x. That's your omega there. That's 2 pi over 2. And that's going to give you pi. So pi would be the answer for part C. That's the time required for one oscillation. It's going to be pi. The last one, what's the frequency? Okay, the formula for that is your frequency. We're starting with that one. Your F for frequency is the same thing as 1 over P, 1 over period. So since we already have the period as pi, that means we just put this in and we get 1 over pi for the answer. So that would answer the last question. We have 1 over pi. So the circled answers here would be it for each one of these parts. And so this is all this question is asking for. Again, they give you the formula, and this question is nothing more than just having you analyze the formula and find out what the different pieces mean in that. So now we've looked at this one, well, I'll just change this and let's do another example. Okay, same type of problem again, but I changed the D here. Now let's look at a different one. This time we're going to look at a cosine one. So we're going to answer the same exact questions we had before in the previous example. We'll just use this one this time. So describe the motion of the object. That's not going to change from what the answer was in the previous problem, because I mentioned anytime you have a cosine or a sine in there, simple harmonic motion. So again, this is going to be simple harmonic motion is the answer for that one. That's the answer for A. Next, for part B, what's the maximum displacement? As I mentioned before in the previous video, that's nothing more than your amplitude. Okay, now we have to make sure we pick the right number here. Your amplitude has got to be the one that's connected to the trig function. We don't want to pick the 2 over here. We want to just use this one. So in this case, the amplitude is going to be the number in front of the cosine there, so your answer is going to be 5. Again, the amount of displacement, that's how far you are away from the rest position, how far you are away from the x-axis or the t-axis in this case, because we're dealing with t. And again, that's just your amplitude. The time required for one oscillation, and as I mentioned before in the previous video, that's your period. We have a formula for period. The period is equal to 2 pi divided by the number in front of the x. Now in this case we have a pi over 3. So if we flip that, we have 2 over 1 times 3 over pi. The pi's cancel, and this time we get a whole number. We get 6. So that's going to be the time required for one oscillation. It would basically it would be 6 seconds, because that's the unit of time that we have on it. In the previous example, that was a pi that we had. That would be pi seconds, so just over 3. In this case we have 6 seconds. What's the frequency? The frequency again is equal to 1 divided by period. So in this case, we're just going to do 1 divided by our answer we got in part C. It's going to be 1 over 6. So that's going to be all the parts answered. Simple harmonic motion, this is 5, your amplitude, the 6 seconds and the 1/6. Now this 2 right here, we didn't have to use that in any of these parts. What that 2 does is it basically takes the graph that normally would look something like this. In this case, actually, it would be a cosine, so make sure it's drawn correctly here. It actually would look like this. But what's happening is the whole graph will be shifted up 2 units. So then the graph will be drawn up here instead. That's what the 2 actually does. It would actually raise the whole entire level up. So that's not going to change anything. If you're raising it up, it won't change your period or your frequency, and your amplitude is still going to be the same. It's based off of your center portion there, how high or how low that you go from the resting position there.